Hello, today we're going to be talking about point forces, and specifically point forces in vector form. So for this particular worked problem, we're asked to basically convert this force vector, which we have in component form, into magnitude and direction form. So I need to find the overall magnitude of this vector, and I need to find an angle that's going to give me the direction. So first thing I do with any of these force problems, if I'm converting between the two forms, I'm going to draw out a triangle. And so my triangle is going to be like so. And so this is my force vector right here. I'm looking for that magnitude. And with this component form, what I know is this first part is the x component. So I'm going backwards by 300 newtons. So it's 300 is the length of that side of the triangle. This is a right triangle. And then negative 250 is the y component, so I go down by 250 newtons this way. So what I want to find is, I'm going to call this f, just the magnitude of the whole vector. And one of the ways we can do this is if we look at, say, let's find this angle, we'll call that theta, and that theta would be this angle in our particular vector or our triangle over here. So let's do this one at a time. We'll start with f. We can use the Pythagorean theorem here. So a squared plus b squared equals c squared. So my force, my magnitude of the force, is going to be the square root of 250 squared plus 300 squared. And the signs don't really matter in this particular calculation. So if I solve that out, I should end up with a value of approximately 390.5 newtons. So that's the magnitude of my overall force, and that's going to be the length of the hypotenuse in my triangle. Next thing I need to do is to figure out my angle theta. So my angle theta, I'm going to use one of my trig identities. So the tangent is going to be the opposite side over the adjacent side. So tan theta would be 250 over 300. And if I take the arctangent, or sorry, the inverse tangent, tan negative 1 of opposite over adjacent, or 250. Excuse me, over 300, I can get an angle of approximately 39.8 degrees. And that's going to be my angle theta. So now that I have the magnitude, I have the direction theta, I can go back to my kind of original diagram, and I'll redraw this. So I had a cantilever beam, which just means a beam kind of sticking out of a wall like this. I had my force, like so, and the magnitude of this force, F equals 390.5 newtons. And I'm going to draw on my angle theta. This was 39.8 degrees. So with that, I've gone from my original diagram here where I just had the force vector in component form, and I've gone back. I figured out the overall magnitude and the direction in terms of an angle. So with that, I've solved my particular problem. Thank you for watching, and hope to see you again.